Hello. There are two questions which need to be discussed, which are very important questions. First one is, find all the roots of the equation cos z is equal to 2. Cos z is equal to 2. We know that cos z is e raised to the power iota z plus e raised to the power minus iota z over 2 is equal to 2. So this is e raised to the power iota z plus e raised to the power minus iota z is equal to 4. Now अगर हम इसको 1 over e raised to the power iota z लिखेंगे तो एलसीएम लेने के बाद हमारे पास एक क्वाड्रेटिक इक्वेशन बन जाएगी which is e raised to the power 2 iota z plus 1 is equal to 4 e raised to the power iota z, which implies further e raised to the power 2 iota z minus 4 e raised to the power iota z plus 1 is equal to 0. So now this is your quadratic equation in e raised to the power iota z. So the roots of e the power iota z is equal to, which is minus b plus under root b square minus 4ac over 2a, where a is 1 and c is 1, b is minus 4. Here it is plus minus, which is equal to 4 plus minus under root of 12 over 2, which is equal to 2 plus minus, this is root 3. Now e the power iota z is 2 plus minus root 3. This is e the power iota z. If I take log on both the sides, I will get iota z is equal to log of 2 plus minus under root 3. Now I am opening this log as log of mod 2 plus minus root 3 plus iota argument of 2 plus minus root 3. This is iota z. Further, iota z is equal to log of mod of this number is, this is your positive number because root 3 is 1.732. Now if you add 2 plus root 3, you will get a positive number, and if you subtract 2 minus root 3, you will again get a positive real number. So this is modulus of positive number is same as 2 plus minus root 3 plus iota. Now the argument for positive real number is 0 plus 2n pi, cos your positive real number lies over here on the x-axis. Here theta is 0. If the number is here, your theta will become pi. So your positive number is on the positive real axis. So this theta is argument is 0 plus 2n pi. Next, I am taking iota z in this denominator. Z is log of 2 plus minus root 3 plus iota, this is 2n pi. So z comes out to be 1 over iota log of 2 plus minus root 3 this is log of 2 plus minus root 3 plus 2n pi. Next, if you multiply with iota and divide by iota, you will get iota over iota square. So above numerator is iota, divide by iota square, that is minus 1. I have multiplied iota in the numerator and the denominator. So this is log of 2 plus minus root 3 plus 2n pi, which is equal to minus iota log of 2 plus minus root 3 plus 2n pi, where n is your integer. So the next question is solve sin z is equal to cos hyperbolic 4 for z. Now first I will check this. Is it a real number or not? We know that cos hyperbolic 4 is equal to e the power 4 plus e the power minus 4 over 2. So this is simply a real number. So I will take this number as a. So I choose a to be equal to cos hyperbolic 4, where a is any real. So now sin z is equal to a. Sin of z is equal to a. Now what is sin z? This is e raised to the power iota z minus e raised to the power minus iota z over 2 iota is equal to a. Next, e the power iota z minus, this is e the power minus iota z, which is equal to 2 iota a. अगेन आपकी फिर से ये क्वाड्रेटिक इक्वेशन बन जाएगी. इसको 1 ओवर ई द पावर आइटा z लिखेंगे तो दिस इज ई द पावर 2 आइटा z माइनस 1 इक्वल टू 2 आइटा a e the power iota z. Again this is your quadratic equation in e the power iota z. Minus 1 is equal to 0. Now the roots of e the power iota z is equal to, what is b? That is minus 2 iota a. So this is minus b plus minus under root of b square, that is 4. This is iota square, this is a square. So can I write minus 4a square minus 4ac. A is 1, c is minus 1. This will be 4 over 2a, which is equal to 2 iota a plus minus इसमें से हम 4 बाहर स्क्वायर रूट बन के 2 आएगा. So this is 2 under root of 1 minus a square divided by 2. I'm cancelling this 2, so I'll be getting iota a plus minus root of 1 minus a square. So this is e the power iota z. Now taking log on both the sides, I will be getting iota z is log of iota a plus minus under root 1 minus a square. Now here your real part, that is this is your x and this is your y. Now opening this as log of, what is the modulus for this number, complex number, that is x square plus y square under the root. So I'm writing such mod log of mod iota a plus minus root of 1 minus a square plus iota argument of iota a plus minus under root 1 minus a square. अगर इस कॉम्प्लेक्स नंबर को एज ऐसे देखेंगे z इज इक्वल टू एक्स प्लस आयोटा y, तो उस केस में mod z विल बी, दिस इज x square plus y square under the root and argument of z is tan inverse y over x plus 2n pi. तो यहाँ पर मेरा y a है और x ये है, और यहाँ पर मेरा y a है और x ये है. So next, this iota z is equal to log of, now I'm taking the modulus for iota a plus minus root of 1 minus a square, that is 1 minus a square plus that thing, I think iota a plus iota argument of iota a plus minus root of 1 minus a square. This is log, this is under root also. A square cancel, so root of 1 is 1 plus iota, what is argument for this, that is tan inverse y over x. Y is a over root 1 minus a square plus 2n pi, where n is your integer. So log 1 is 0 plus iota tan inverse a over under root 1 minus a square plus 2n pi. So my z comes out to be iota cancel, this is tan inverse a over 1 minus a square under the root plus 2n pi. Now what is my a? That is cos hyperbolic 4 over 1 minus a square under root will be 1 minus cos hyperbolic square 4 the under root, that is sin square hyperbolic 4, square और root कट गया तो sin hyperbolic 4 plus 2n pi. Further it is equal to tan inverse, what is cos hyperbolic over sin hyperbolic, that is cot hyperbolic 4 plus 2n pi, where n is your integer. This is the solution for the above equation. So now in the next class I will be starting a new topic, that is branch cuts, branch lines, Riemann surfaces, so on. So thank you very much.